we, or at least most astronomers, are obsessed with a clear night sky. And it's important that it's so important to us that we have honored our most honored myths and legends to be a part of that sky. So we put the legends of Perseus and Orion and Hercules into the sky. And we actually have a flying horse that runs through the sky as well. So we look up to the sky and we believe that the sky holds heavenly secrets. If we stare up in the sky, we find that we are somehow moved by its beauty. And if the heavenly, if the heavens are something that's good, then it follows that what's on the other side may not be so good. Perhaps a place for politicians to go. But the sky does hold so many secrets, and it is part of our history, it's part of our mythology. It's really quite a, a fulfillment of being being a part of the high ground. And so when rulers, when kings and such built their castles, it was always, they were always built on the high ground. This was not only a way of getting closer to heaven, but it was also a pretty good way of defending what you had. Even the force has a high ground. To reach that high ground, man's quest drove him to learn how to fly. And when he learned how to fly, um, actually, he found all sorts of ways of doing that. Even other animals sought to find ways of flying. We all know the myth of Icarus and Daedalus, where they formed wings out of feathers and wax, but Icarus flew too close to the sun. And as you can see, uh, he lost his cowl. Plus, he lost other things too, but that was what this picture shows. Well, anyway, actually, 2,000 years ago, it was the Chinese that actually tied people to kites and they flew them. The kites looked like butterflies because they figured that's what they did. And as you can see, sometimes they don't work as well as others. Now, a Chinese emperor by the name of Wu Han decided that he was going to fly as well. And he took his throne and he formed a lot of rockets to it. And when he went ahead and had his servants light the rockets, uh, he prepared himself for liftoff and he decided he was going to go to the moon. And you know what? He made it. This is the crater Wuhan on the moon. Not quite sure. Well, that's anyway, but there's Wuhan on the moon. During the late Middle Ages, Cyrano de Bergerac and Francis Godwin devised ways of getting to the moon as well. Cyrano said, why don't we just simply tie um, some receptacles with the morning dew around you. So when the morning dew evaporated, it would take you with it. Francis Godwin had a better plan, and he just simply tied several hundred goslings to uh, a frame so that they would fly him to the moon. I don't think either of them worked. However, in the 1700s, brothers Montgolfier in France actually used what they called Montgolfier gas, which was simply hot air, and actually had their balloon rise with the hot air. Now, in order to actually experiment with this, they had a sheep, a duck, and a rooster fly along, figuring that if something was expendable, definitely a sheep, duck, and rooster would be. The balloon reached an altitude of about 6,000 feet and landed about a mile away. And they found that the animals were fine. They actually uh, lasted through the trip and were just fine. So they went ahead and they went up themselves, and they found that they were actually it was actually a wonderful way of looking down from great heights. And suddenly the uh, the method of doing high altitude reconnaissance uh, became a part of the Army's repertoire. During the Civil War, balloons were used quite often in order to take a look at troop movements and other things that were needed in order to fight battles. The problem with balloons, other than the fact that they would drift off, if they were tied to the ground, these reconnaissance people were literally sitting ducks for anybody with a rifle to shoot at them. However, with the invention of the airplane, uh, they found that high altitude reconnaissance was a little bit safer if they were actually flying around. This obviously became the way that things were done as far as reconnaissance was concerned. And right now, the U-2 is our high altitude aircraft that does some pretty interesting reconnaissance from about 70,000 feet. It used to be beyond the range of anything that they can shoot at it, but that's changed in a little bit more modern times. Uh, so what does this have to do with Drake? Well, actually, as we're looking through the atmosphere, what we find is the fact that we are limited as to what we can see. Looking at reconnaissance on the ground, we find that it's a little bit fuzzy, especially when you look at it from 70,000 feet. We have a problem with that. And it was decided, actually, it was Dr. Morehouse who decided that they need to take the observatory and move it to a clear spot. Now, at the time that Drake was built, this is again around 24th, 26th Street, and they felt that the area was too close to downtown. And as a result, the air needed to be cleaner in order to be able to see things a little bit better. It was subject to the lights and the pollution of downtown. And if we take a look at some of the pictures that were taken of downtown, you can definitely see why they decided to move the observatory. So there was an awful lot of, shall we say, industry going on downtown. And one of the things that absolutely startled so many people with the recent COVID-19 quarantines, things that looked like this is Los Angeles on the right, and we have the Grand Canal in Venice, Italy on the left. And after a couple of months of quarantined, this is what they looked like. So it's just amazing how much the air cleared in the months that industry and people were, well, they were unemployed, but they certainly weren't doing uh, anything on that. But this is the War Memorial at New Delhi, and you can see that during the time of the quarantine, things definitely cleared up. So that was one of the main reasons why they wanted to move the observatory, to get it out of the light and goop, shall we say, of the downtown air. There were other reasons as well. For one thing, the building that it was in was not well constructed, and as a result, every time a trolley passed, it would vibrate. So it was not a very good uh, structure to have a telescope. Now, Dr. Morehouse played golf quite a bit at Waveland Golf Course, and he liked the high ground once again at Waveland, and he decided at this particular point that the observatory needed to be on the high ground at the golf course. So this is what he envisioned. So what actually makes the air usable or unusable is actually gravity. The atmosphere is pulled by gravity. So near the Earth's surface, the air is denser. In fact, if you were to have a column, actually weigh the column of air that starts from space and goes all the way down to the ground, you can actually weigh that as being about 14.7 pounds of air per square inch. And most of the Earth's, almost all the Earth's atmospheric gases are within 30 to 40 kilometers of the surface. So if you were to actually measure, once again, measure that, it's about 14 pounds per square inch. And all that air is in that very narrow green line that sits above the Earth. We are protected by that green line. Everything that gets thrown at us, like meteors and stuff, will actually go through the 30 or 40 kilometers of air, and the friction of going through that air will actually burn it up. But what's even harder is the fact that when we look through that air at things in the sky, it looks foggy way up in that upper left corner. That is actually a star. And as you can see, the air is churning enough so that star will jump around. It does not give a good image. And then we have the picture of the moon, and the picture of the moon, as you can see, is uh, pretty foggy. It's very hazy. Once again, because of the fact that the air will break up the light. Anything we see that's, well, in this case, it would be about 100 miles up. That's the International Space Station. And even that would look fuzzy looking through our atmosphere. And our atmosphere has uh, water vapor and all the other gases that oxygen and nitrogen, and all that is actually covers the Earth and is broken up by our atmosphere. The atmosphere uh, is constantly churning, being blown around by the wind, and it doesn't give a very good image. Now, we could reduce that problem by simply, uh, shall we say, building the observatory at a higher place, like a mountain or something like that. And there are some uh, high level observatories that would be hard to get at, definitely, but do give do tend to give a slightly better image because they are looking through less atmosphere. They would also be very cold uh, once you're up there, and waiting online to actually look through the telescope would definitely be a test of character. This is Peak Observatory. That's in Tucson, or just south of Tucson, and it has a wonderful view of the sky. It also has a wonderful public program where you can actually go there and look through telescopes. Uh, they also give you a nice sandwich because you have to wait until it gets dark. But the thing that they have done recently, they've actually made it possible for telescopes to adapt to the fuzzy sky. It's called adaptive optics. And what they do, they actually shine a laser through the atmospheric turbulence, and they analyze how the atmosphere takes that laser light and bends it and uh, makes it, that's how we say, unusable to look through. And then they have a deformable mirror that will take the light from what you're looking at and will mimic how the atmosphere is bending that light. Obviously, all this is done through a computer, and when it's all done, they will actually have an image that is rock steady and uh, as though there was no atmosphere there. As a result of these adaptive optics, they have telescopes on the Earth that work as though there is no atmosphere. And the pictures have been absolutely breathtaking. As you can see, it does actually get rid of the fuzz. Planet Neptune, and again, using with these new telescopes that have multiple mirrors, they can send a laser out, and each mirror will have its own adjustment. In this case, 1,000 times a second to adjust for the for the atmosphere that is jumping around. One of the things they've been able to do with these adaptive optics is actually take a look at the center of our galaxy and watch the stars that orbit our supermassive black hole. Now, these were taken over years. You can see the year counter in the upper right. So this would take, in this case, pretty close to 20 years to get this type of image. But again, this could not have been done if adaptive optics were not uh, figured out. So we have telescopes that are capable of taking clear pictures through an atmosphere. Well, what else do we need? Well, unfortunately, our atmosphere not only takes the image and makes it fuzzy, but it blocks a lot of the light that comes to us. Infrared, the longer infrared radiation, all the high energy radiation, all that is blocked by our atmosphere. The oxygen, nitrogen, and the water vapor actually blocks most of that light. So we need help in order to be able to see those particular frequencies. Now, believe it or not, there is someone who can help with that, and her name is Sophia. Well, actually, Sophia doesn't really help with that. Actually, it's this Sophia. The stratospheric observatory for infrared astronomy. This is the longer wave infrared astronomy. And riding in the belly of the 747 is a telescope that's 100 inches wide and capable of seeing well into the infrared range, because at 40,000 feet, this airplane is actually flying above 99% of the atmosphere. So it's capable of seeing the far infrared. And as a result of that, we have a flying infrared observatory. Now, this doesn't fly tremendously often. It's actually a joint effort by Germany and the United States. But when it does, some of the pictures, some of the information that it's capable of gathering is just mind-boggling. Now, there's other ways of actually getting higher than this, and that's by using balloons. A balloon will rise. As it rises, the air pressure gets less and less until finally the balloon bursts, and then a parachute will bring down the instrument package. This is being done now by a school in Bishop, California. This is a high school, and they put together a program called Earth Sky Calculus. And what they do is send up balloons about every month or so, and actually take readings of the gamma radiation. Now, if you're wondering, how do they fund this? They attach things to those balloons, and they sell them on, well, actually, it's sold on spaceweather.com. And well, they're not cheap, they're about $100. But they have been in space, and you have a certificate of authenticity that they've been in space. So if you want to get something along those lines, this is available. Again, spaceweather.com, and you'll be able to find that. So what have they learned from all this? What they have learned is the fact that our weather is affected by cosmic radiation coming from out in space. And our sun, which does protect us against some of this during times of quiet sun, these cosmic rays will actually reach the Earth and cause different, shall we say, different problems that would cause heavier and more, shall we say, more often there'll be clouds than during times of high radiation. So these readings are actually used to predict weather. Now, there is also another type of, shall we say, a balloon, and that's a balloon that's actually attached to a rocket. These were developed in the late 50s, and as a result of these things, they can actually take uh, take about 25 kilograms of mass and actually put it into orbit. Now they can do it cheaper than anything else. And there was a company that actually put together a program to send up small satellites into Earth orbit. And as a result of that, they were going to, shall we say, have the industry together to be able to send more and more things into space. So this was a system designed for microsatellites. Unfortunately, they did not get the funding that they needed to do this. So this particular project, if you'll excuse the pun, never got off the ground. Now there's another problem when you're dealing with things on the Earth, and that is light pollution. There is a major problem happening right now that concerns light. This is in Los Altos Hills, California, and this is actually somewhere after 9 p.m. And you can see that it's very hard to see stars there. And this shows the encroaching light pollution coming in on Palomar and Mount Laguna observatories. And you can see that Palomar at this point, this was about 3 years ago. So at this point, Palomar is almost useless. It's very close to useless. Just outside of Tucson, we have the multi-mirror telescope. And this shows it sitting on top of a mountain on Mount Hopkins. This is in 2005. And if we were to take a picture of the surrounding area around the multi-mirror telescope, it would look like this. So you can see the multi-mirror telescope is on the verge of becoming useless as well. What light does to any kind of image that you're looking at, it just destroys it. Or here you have a house that has an outdoor light, And immediately you can see that stars are absent until they turn off the light, and then suddenly the dark sky appears again. When I lived in New York City, and I didn't realize how dull the sky was until I came out here and saw Orion like this on the left side, as opposed to what I saw Orion in New York on the right side. And you can see that, okay, there you can see the Orion Nebula, and I was pretty happy to see that in New York. But in Iowa, you can see it so much better. By the way, these pictures were taken in the about the late 1970s, and I can tell you that Orion doesn't look like that anymore because of the light pollution that's here. There is the vision from Mount Palomar, and you can see that even from Mount Palomar, the light from the casinos and Candido have basically eliminated that part of the sky. And on the bottom, we have the type of lights that we would need to have in order to keep the sky dark. What's interesting is the fact that in downtown Des Moines, there is something called the River Walk, and they've put excellent lighting around the Riverwalk, where all the lighting is focused down on the ground. So it's a real good start for getting our night sky back again in downtown Des Moines. The trouble is all the other lighting downtown is the quote very bad lighting. So even though they have good lighting at the Riverwalk, everything else down there is pretty bad. Our nation has undergone a, a transformation from a night sky to the point where we are almost without a night sky here in the United States. You can see how much the sky has changed in the last 50 to 60, 70 years. And it's only getting worse at this point until cities legislate the fact that you can't use very bad lighting, what they've called bad lighting. This is a picture of the what they call the light print or the light footprint of the various cities in the United States. There's central Iowa. And I guess it doesn't look that bad until we overlay on top of this how much that light actually affects the sky. And immediately you can see that our sky is not dark, even as far as 50 to 60 miles away from any area that has light pollution in there. The darkest areas, as you can see somewhere actually west of us, are the places where you have a possibility of seeing a good night sky. So where do you put a telescope? Where can you put a telescope where the night sky, where you can actually see the night sky? Well, right now, they're looking at South America. There's a place, actually, there's a couple of places in South America where the sky is extra dark, where the humidity is low, and you're on top of a mountain. And you can kind of see it on the west side of South America. Right there, we have the place where the extremely large telescope is being built. The mirror on that telescope is 129 feet across. 129 feet. Palomar is about 16 feet. So that'll give an idea of the scale that we're talking about. The extremely large telescope, that's its name, by the way. Well, I've always said that astronomers do not have a good imagination for making up names. So this is called the ELT, or Extremely Large Telescope, and it's being built by the European Space Agency. Now, the US is building its telescope. That's called the giant Magellan Telescope, and that's a couple of 100 miles south of there. And that one is only 85 feet in diameter. So at that point, you are looking at some tremendous amount of light gathering ability. These are light buckets to the nth degree. I mean, they're going to do some amazing work. But once again, we are stopped by the fact that we are on the Earth and we cannot see through some of our atmosphere. Our atmosphere is actually stopping the ability to see through the infrared and the high energy uh, radiation that's coming from stars and planets. So we have to be able to get above that stuff. And to do that, we call upon the genius of Robert Goddard. And Robert Goddard in the early 1920s actually invented the liquid fuel rocket. Now, what's so neat about a liquid fuel rocket? It's the fact that you can control it. Now, when you have a firework that uses a chemical uh, uh, propellant, you light it and you basically run away because you have no idea how that's going to go. With the liquid fuel rocket, you can turn it off and turn it on, turn it off. You can have a limited amount of fuel going. You can control it, control how high it is, control how fast it can go. And as a result, you're able to get a lot more research being done. So he put together his rocket. I can't remember how many patents he has, but a pretty good number of that. And he was able to experiment and send it off. By the way, this was in downtown Worcester. He's worked on some larger rockets, and he's also did an amazing amount of research on liquid propellant rockets and methods of reaching extreme altitudes. Now, when he's talking about extreme altitudes, he's talking about actually going to the moon. And he wrote, his papers on this, and it was the New York Times that basically said, in order to get a rocket into space, the rocket has to push against something. And the vacuum of space does not provide the ability for a rocket to move. And they said, of course, he's only missing the knowledge ladled out daily in high schools. Now, we all know that to be, we all know about the New York Times and the fact that it's probably the editor that never went to high school. And they finally retracted this particular editorial on July 19th, 1969, while the astronauts were on their way to the moon. All they had to do was to actually watch a newsreel of actually the first research rocket ever sent into space. Of course, it didn't quite make it to space, but I'll let you watch that. Of course, not all rockets were successful. Oops. Some of them were partially successful. This one reached an altitude of about 10,000 feet before it finally veered off. These sounding rockets were sent up several times a year and did some amazing research in the infrared range. But it was in October of 1967 that the world was startled to find out that Russia had the wherewithal to be able to actually put something into orbit. And that changed research, just basically put it on its head. Because if they can take a satellite and put it into orbit, then they can take an atomic bomb and send it over to the United States. So this caused a lot of problems for the US. Now, the satellite that they put up there, Sputnik, actually did almost nothing. The only thing it had in there was a transmitter that that actually broadcast a single signal about every 15 seconds. That's all it did. But it was enough to scare the heck out of everyone in the United States, actually the whole world. So the US immediately started working on their rockets and they had a little problem. This was the Navy Vanguard rocket. And at this point, President Eisenhower decided he was going to get the Army involved in this. He didn't want to do that because the person who was in charge of the Army missile program was Dr. Wernher von Braun, and he did not trust him. Von Braun was a Nazi, and as a result, Eisenhower wanted to keep von Braun away from being able to boast that he put a rocket into orbit. The rocket that he was looking at was the Mercury Redstone. Actually, it was the Jupiter C at that point. And as you can see, it's considerably smaller than the R7 that the Soviets used. There's von Braun at about the time that this was happening. And in order to get von Braun involved, he actually took the Army out of the role of a missile research facility. The President Eisenhower simply took it over. Meanwhile, the Russians actually at this point put a dog into orbit. There was no intention of ever getting that dog back. The dog actually succumbed to heat and exhaustion after about 10 to 15 minutes. It's really too bad. But the Russians did make a lot of use out of the publicity that they got from being the first to put something into orbit, and certainly beat the US by, well, actually it was by 59 days. We did manage to get something into orbit, and that was Explorer 1. Explorer 1 took off from, at that point, it was Cape Canaveral, and it orbited the Earth for a number of days, where it actually did something. It discovered radioactive belts going around the Earth that seemed to align itself with the uh, uh, magnetic field. As a result of this, a lot of the pathways that our manned space program used in order to get astronauts to the moon actually were modified not to fly through the radiation belts, or to just skim them as opposed to flying through them. These belts are named after Dr. James Van Allen, and we still we're finding these belts around a lot of other planets as well. So they found that they can use rockets to get above our atmosphere, to be able to find the radiation, actually learn from the radiation that cannot get through our atmosphere. Right now, there are literally dozens and dozens of space probes that are in orbit, not only around the Earth, but also around the sun, that are learning about high energy radiation, that are learning about infrared radiation that's coming from not only other stars, but also from planets and other objects that are in space. In fact, we have so much in orbit around the Earth that it is becoming a headache. We have several thousand probes circling the Earth that are actually learning about things in space, but also are they're also using them to have radio and television programs. Almost all the football programs are being broadcast from satellites that are orbiting our Earth. And as a result, we have one more problem that's now being looked at, and that's actually being caused by SpaceX. SpaceX is sending out literally hundreds and hundreds of little mini satellites. These are designed to orbit the Earth. There's almost 12 1,000 satellites that are being put up there. These are actually called Spacelink, and this is a way of making the internet available for everyone on Earth. But when they send them up, these little mini satellites reflect the light of the sun, and we see a line of satellites that will affect our seeing. About a year and a half ago, there was a meteor shower that was pretty rare. It's called the unicorn meteor shower. And they totally bombed the viewing of this meteor shower. So we have one more problem with looking into space. Now, SpaceX said to reduce their reflectivity, they will paint these little mini satellites flat black. Now, I don't think that will solve the problem. And the reason why I think that is because when you look at the reflectivity of the moon has the reflectivity of actually less than that of what Sears calls its flat black paint. And the moon's ability to reflect is still quite a bit when you start looking at it. So I'm not quite sure that the flat black is going to help that much. So until the time comes that we are no longer able to look at things in space through telescopes, we have to rely on telescopes that move beyond our Earth. The James Webb Telescope will be placed into solar orbit, hopefully this October, and we'll be able to see a lot further. So at this point, looking at next week, so next week we are going to look for some neighbors. Okay. Okay, so at this point, I think I'll go ahead and we'll let you unmute yourselves. If you have any questions, I'd be more than happy to answer them.